back to our channel. This week we're looking at volume and surface area. Now, I did a maths degree, not an art degree. This is a quarter of a sphere. The question is on the screen and we have linked it down below, but use your imagination because I know. But let's get to it. We currently have the volume of quarter of a sphere is 576 pi. We are given the volume of sphere, 4/3 pi r cubed, and the surface area of a full sphere is also 4 pi r squared. We want to find the surface area to three significant figures. So, before we jump in the question, what do we need? Well, simply put, we need the surface area. We have the 4, we have the pi, we need r. Cool. Keep working backwards. How do we find r? Well, we have volume, we have the volume equation. If we rearrange this, we can get r. Amazing. But this is volume of sphere. This is a quarter sphere. Therefore, if we do a quarter of this, we can equate it to this. There we have created our 3 clear steps. Equate volume to find r, substitute r in, answer the question. Let's begin. So like I said, we have 576 pi is equal to a quarter of the volume of the sphere. We can simplify and multiply across. That's going to be 1728. And before I continue writing, we can also cancel out these pi's. So we're left with r cubed. And then we rearrange it and cube root both sides to give us 12. Now, there's a paper 2 question, so if you do get a calculator, don't expect to do that in your head. Lovely, we found r, so just a recap, we want to then use r to find the surface area. Now if we take a step back, surface area of a sphere would give us the outside of the sphere. And the outside of my lovely looking sphere is only this bit. So what a lot of students will forget is that these 2 bits are still touching the outside. So if you will, you can still physically touch those bits, meaning they still count as surface area. So we will work on the blue bit first and then come back to the bit in green. So for the bit in blue, it's just the normal equation, but it's a quarter of it. So we want to find a quarter of the surface area of a sphere, which will give us a quarter of 4 is 1. So we're just looking at pi r squared. We have r, we sub it in. That's 12 squared pi, and that gives us 144 pi. Cool. If you stop here, you're looking to lose maybe 2 of the marks. So now the green bits. If we just ignore this, that, and maybe from the actual diagram, you can see that's half a circle. And it makes sense why it's half a circle. And if that's half a circle, that's also half a circle. So you combine them and you've got 1 full circle. And you know the area of 1 full circle is pi r squared. This has the same radius as this. It is obviously a circle, therefore the radius doesn't change. And we therefore just sub 12 in to give us 144 pi again. Therefore the total surface area is equal to 144 pi plus 144 pi. That is 288 pi. Cool. We'll take a step back. We reread the question one more time, and specifically the last line. Find surface area, check, to 3 significant figures. So we put this in our calculator, and we write down the answer to 4 significant figures. So that's 904.7. We write ... to show the examiner this is only part of the shown answer from the calculator, and then we round it ourselves. And we put our units back in, and we write 3SF. So from here, why have I done what I've done? Well, this here is good practice. Units sometimes will be a mark, but usually your answer box will say centimeter squared, but sometimes they'll try to trip you up. So again, good practice. This is a mark if this is wrong. So again, good practice. And everything else should be clear and coherent. Well, that's a good way to end it. Let me know what you thought, and we'll see you next week.